everyone, and welcome to STEMfest 2015. My name is Bradley Layton, and I'm a professor at the University of Montana, where I direct the Energy Technology program. Before we get started, I want to thank you for spending time with me, Governor Bullock, and the fine folks at the Inspired Classroom, and an organization known as We Are Montana in the Classroom, who place University of Montana faculty members, graduate students, and professionals in K-12 classrooms statewide to inspire them about higher education and career pathways. Today, with the technology provided by VisionNet, we are able to fulfill this mission. This event is part of a national initiative called STEM Career Accelerator Day, being hosted by STEM Connector. You can find more about their organization at stemconnector.org. My first connection with STEM Connector came through as a result of a National Science Foundation grant I received through their Advanced Technology Education Division to enhance the educational opportunities for my energy technology students, a few of whom you see behind me, to strengthen our relationship with the Blackfeet Community College, to build connections with renewable energy technology companies, and to build connections with high school students around Montana and across the United States. You probably already know this, but the presentation you're about to take part in is a minds-on activity. So get comfortable in your seat, take a deep breath, and get ready to meet and interact with some of Montana's leaders in science, technology, engineering, and mathematics. Now, I'll hand it over to Governor Bullock, who would like to share with you his vision for the future of STEM education in Big Sky Country.
Hi everyone, I'm Governor Steve Bullock, and I'd like to thank you for being a part of the first ever Montana STEMfest and showing an interest in a career in the fields of science, technology, engineering, and math. These are some of the fastest growing career fields in the nation. In fact, over the next decade, Montana is expected to need more than 2,000 new workers a year with skills specific to these fields. And these are good paying jobs in careers such as engineering, research and technology, architecture, and health sciences. I've been working hard to ensure that students like you have access and support to succeed, which is why we've created the Governor's STEM Scholarship Program to provide financial aid to students pursuing one of these careers. We've also launched the Montana STEM Mentors Initiative to encourage more girls to pursue a career in these fields. You all will determine what the future of Montana looks like, and your participation today means that we will have a bright one. Thanks so much for being here and have a great time.
My name is Whisper Camel Means. One of the great things about where I'm from and where I work is on the Flathead Indian Reservation. We have a lot of different cultural and natural resources available to us. You can hike in the Mission Mountains, swim in the Flathead Lake or Flathead River, and go soak in natural hot springs, all in one day.
Awesome. Paul, how about you?
Hi, yeah, thanks. My name is Paul, and I work for Trout Unlimited. I live in Missoula, and similar to Whisper, one of the great things in Missoula is that we have a plethora of rivers, one that rolls right through town, and it's just great to be able to have clean rivers that flow right where you live.
Fantastic.
All right, yeah, like Ali said, my name is Paul Parson, and I work for Trout Unlimited. I'm a civil engineer with a background in bioresources, so I basically had to study a lot of math, science, and obviously engineering. And I use a lot of technology in my work on a daily basis.
You're doing good.
Okay. So just to start it off real quick, Trout Unlimited is an organization that works to conserve, protect, and restore North America's coldwater fisheries and their watersheds. And what that means basically is we try to work with governmental agencies and people to not only protect water to keep it clean before it's messed up, but if it does get messed up, hopefully we can come in and help clean it up. Leads to the question of why should we restore streams? And I want to point out this photo if everyone can see it. This is a group of students that we worked with prior to a restoration project. And it's a technology that we use. We use electricity to actually shock fish, and then we catch them and count them for background before we start any of our restoration work, just to see what was there before we started, and then we know how it is once we're done. But why do we restore streams? Well, a lot of times streams in Montana are in pretty good shape, but a lot of them aren't in good shape and populations have crashed and or they're non-existent. So when we fix streams, there's different parts of the stream that we need to fix. It's not just we're going into the channel and fixing just the channel. We also need to fix wetlands and all the connected areas of stream systems. One of the techniques that we use is repairing the riparian, the stream banks, and the wetland areas is using willow sources. And we cut willows to help build banks because they'll grow. So as you can see, it includes a lot of engineering, but there's also, we trust a lot of biologists. We have teams of scientists that we use with backgrounds in chemistry, ecology, biology, soil scientists, and geologists, lots of ologists. So we rely on a lot of people to make decisions on how we should restore things. Show of hands really quick. How many students here have seen a stream restoration project? Just a few? Not too many. All right. Another thing that we work on is dam removals where we have old dams that are no longer functioning. Part of the reason that we want to remove dams is that they're actually barriers to aquatic species going upstream. And a lot of times we think of aquatic species as just being fish, but you also have to think about different life cycles of all kinds of different animals. You have otters, insects, beaver, and then on top of that, fish. But when we have dams that block the rivers, a lot of times that stops migration, which are very important for different life cycles of different age species. So this is an example, if you can see, of a dam before and after removal, and you can see that opens up the stream quite a bit. This is in Wyoming on Spread Creek on a project that Trout Unlimited did. This is just an example of reconnecting a channel. You can see the channel here is really straight, and then you can also see the old channel as it was before it got moved to the side of the valley. A lot of times, 100 years ago, people that were looking to hay good ground would move streams to the side of the valley in order to be able to produce hay for agriculture. But what that did is it straightened the streams and made it poor habitat for aquatic species. So this is an example of what we can do to take streams and put them back to where they used to be. You can see all the meanders here in that restored reach. What I particularly work on a lot of abandoned mines in western Montana in the Clark Fork watershed. And here's an example of some mining practices that are really typical around Montana. I imagine that almost everybody that's joining us today within an hour of where you are, similar mining practices like this occurred at the turn of the century. And this is placer mining, and they're basically looking for freeform gold in river systems. And a lot of times you'd use big equipment to kind of dig up the stream bed and the banks and then wash it down and try to wash the gold out. Well, it's a very effective way to obtain gold out of the stream, but it's also can affect habitat immensely. And then we're left with the aftermath where we have very poor habitat. This is a more modern picture of a lot of what we try to fix, and you can see the bigger equipment working the stream and washing the gold out of the stream. And this still is occurring in Montana in quite a few places to get gold. So what we do is we work to put streams back after this mining has taken place. One of the technologies that we use quite a bit is a technology called LiDAR, light detecting and ranging. Has anyone heard of that technology? No one. All right. So basically, it's you use an aircraft to fly over an area, and the aircraft shoots laser beams down at the ground. Sounds pretty high tech. about 30,000 laser beams per second. And because the plane is hooked to a GPS, it knows exactly where the lasers are hitting, and it actually measures the lasers as they bounce back. And it can create a three-dimensional model. And so we'll utilize these three-dimensional models to guide our restoration and help us make decisions. Here's some of the results in mapping that we get from LiDAR. And as you can see, this is a map of about a 2-mile reach of 9 Mile Creek. This is one of the projects that I work on now. And as you can see, there's a lot of straightened river channel, and those are old mining piles. And like I said, this is about a 2-mile reach, so it's a pretty large area. And what we try to do is we try to rework these streams so that they have a lot of sinuosity like we saw before, instead of the straightened reaches. So it takes quite a bit of big equipment reworking these mine piles to recreate the stream. This is an example of how we use drafting with those models. And as you can see, the blue here, that dark blue area, that is the existing channel that had been moved to the side of the valley. And it's really poor fish habitat. It doesn't work well for fish because it's so straight. There's not good quality vegetation that can grow in that channel. So you can also see that we have this sinuous channel designed in, and that's where the engineering comes in. But we rebuilt this channel like this last fall and to get the meanders back into it and reconnect it to the floodplain. This is another example of that same reach, but we hand over our engineering plans to plant biologists and ecologists, and they take the plans and they decide which plants should go where. And they draft up, on top of the engineering plans, they draft up these vegetation plans that show what structures should be where, because riparian plants will go better up in the riparian area, whereas willows or wetland plants should go in the wetlands. And so we work with teams of different scientists that have different expertise to develop these whole-scale plans. So this is an example of the creek that we restored last year after restoration, and you can see basically all these willows through here that are starting to grow as of this spring. This was this fall. And so you can also see that it's got a nice meander, and that's a pool habitat there that didn't exist before. That's sitting where we had mine piles for about 100 years, and we put the stream back into the center of the valley where it probably was 100 years ago. And that's pretty much all I have for my presentation.
So yes, my name is Whisper Camel Means. I'm an enrolled member of the Confederated Salish and Kootenai tribes, and I'm a wildlife biologist working for the tribes. The area that we manage is the Flathead Indian Reservation that is home to the Bitterroot Salish, the Pend d'Oreille, and the Kootenai people. Our reservation is 1.25 million acres. My grandmother was one of the last Pend d'Oreille tribal members, one of the last full-blood Pend d'Oreille. And so when we talk about Salish, the Pend d'Oreille and the Salish are both Salesian-speaking tribes. That's the language group. So when we say our name of our tribe, the Pend d'Oreille and the Bitterroot Salish get grouped into one because of that language group. So that's why you don't hear the Salish, Kootenai, and Pend d'Oreille very often. Sorry, I gotta get my slides right. So I attended college at multiple different institutions. When I was going to high school, I was kind of a socializer and not such a great student. And so it took a while for me to get to a position where I was really into college. I did okay in school, but one of the classes that I really liked was science. And so when I graduated high school, I worked for a little bit and then realized that a college education was going to make me more money than not having one. So I started school at Salish Kootenai College. That's a tribal college in Pablo, Montana. And it's the same as a junior college or a A community college is kind of a nice stepping stone between high school and a university, if maybe that's what you need in your life. So I studied environmental studies at SKC. Then I transferred to the University of Montana in the College of Forestry and Conservation for my bachelor's degree in wildlife biology. After that, I received a fellowship to attend Montana State University, and I have a master's in fish and wildlife management from there. I'm going to get this right. So the Flathead Indian Reservation is one of 7 reservations in the state of Montana. They represent 13 different tribes. So each reservation generally was a grouping of different tribes. Not all of them. Blackfeet, I believe, are the Blackfeet people, where the Flathead Reservation is 3 different tribes. Rocky Boys 1, Fort Belknap, I believe, is 2. The Little Shell, which is a tiny little dot, now I'm going to pop back in the screen right here, is a non-treaty tribe but is recognized by the state of Montana. So the Little Shell people do not have a set reservation, but they have recognition by the state of Montana. These are our historical lands. So you can see all the reservations in the state of Montana, but historically our peoples were more regionally spaced and had territories that extended farther than just the current reservation set by treaties where we reside today. In our tribe, we have a natural and cultural resource hierarchy. So we have the tribal council, and they're directly consulted by 2 different culture committees. The Pend Oreille Culture Committee is separate from the Kootenai Culture Committee is separate from the Salish and Pend Oreille. So they give direct counsel to the tribal council on how to make decisions on things that affect the daily life. And then from there, we go down under the tribal council is natural resources, where I work, historic preservation, which also has relations to what can be done in forests, and also forestry lands, tribal health, all the actual like social services. This is a picture of everybody, all the wildlife biologists that work in our department. At this point, we have 3 women and 6 men that are all wildlife biologists working for management on the Flathead Reservation. This is a little map that we had created that all of the colored sections on this diagram of the reservation are protected lands for fish or wildlife. They were either brought apart by state protection, by Montana Fish, Wildlife, and Parks, federal protection, like the National Bison Range, that's federal protection. The pink sections at the north and south ends of the reservation are cultural areas where only tribal members are allowed to go. But we also have land trusts set on private land that's specifically set aside to protect wildlife. This is a land status map, and I don't know for sure if it's going to work. I think it's going to work. But it just kind of shows land ownership through time on the Flathead Indian Reservation. So back in July 16th of 1855, when the treaty was signed, the entire reservation was under tribal ownership. There was a allotment act was passed in the early 1900s. The pink showing the National Bison Range, which was a piece of land taken by the federal government for a bison preserve. And then the orange sections start to show where homesteaders started to come onto the reservation and Indian land was sold to non-tribal people. In 1910, there was another rush of homesteading, and even more tribal land was sold to non-tribal people for non-tribal interests. And again in 1922. So the green section is all land owned by the tribes on the reservation, and the other sections are parts that are not. Then we get into 2015, and the tribes are at the point where we own 65% of the reservation. We've been able to buy that land back and been able to acquire it through different land trades. One of the things that really got me set in this in science is when I was in high school, in small town Sunburst, Montana, the best thing was to get out of town and to go to the science fair in Missoula. So we got to do fun things like create cool artsy kind of boards and do a science project. And we went to the science fair, and it was one of the classes in high school that I actually felt like I fit in and I felt like I was good at. And then when I went to the science fair, I won some awards, and it really instilled in me the desire to study science in the future. So a little bit more about what we do on the Flathead Reservation for managing wildlife. We manage wildlife conflicts, so anytime there's problems with grizzly bears on the reservation, we're out there trying to take care of them. This is one of my coworkers, Stephanie Gillen. Black bears are a huge concern that we're always dealing with, so it's not that we don't want those wildlife there, it's that people and wildlife living on the landscape together often create conflicts. Another picture. Grizzly bears. When we talk about technology, GPS collars are one of the things that we use to track grizzly bear movements throughout the valley, and we have a lot of data from them. We're also putting GPS collars on wolves, as you can see right here on its neck. And you can kind of see its foot right here is a little swollen and red. Those wolves are captured by a leg snare, and in order to make sure that they keep that collar on and are running around the landscape, we have to treat that with antiseptic and treat anything that happens while they're in our care. So anytime we get a large predator or any animal in hand, we have to do all we can to keep them protected because we need the data off their collar. So this is just getting the collar on. We also do native species restoration. These are trumpeter swans, which used to be on the Flathead Reservation in the late 1800s, but were hunted out for fashion, for ladies' hats and such. And the cool thing is, this morning when I was driving to do this presentation, a group of 6 trumpeter swans flew right over the highway right in front of me as I was driving down here this morning. That's amazing to see. These birds have a 6-foot wingspan. This is just a picture of one of those collars, and the picture that kind of has the T04, it has a little white piece on it with an antenna. That's also a GPS transmitter, so we can see where those trumpeter swans head. Another species that's been extirpated that we're working to bring back is the northern leopard frog. We actually go to the Blackfeet Reservation and the Fort Belknap Reservation to get the frogs. We have cooperative agreements with those tribes to collect eggs, bring them back to our reservation, and try to raise those frogs up. I think we're in about 10 years of this project, and last year we actually had calling reproductive frogs, so now that we can get our own egg masses on our own reservation. Another cool thing we do is monitoring crossing structures. So if you've seen the overpass on US 93, that's one of 42 crossing structures that are under and on the highway. Some of those are the expansion bridges, which were just small bridges, but now are expanded so that wildlife can actually have a pathway to walk under them. We also have the overpass. And if you've seen these signs with the native language and the English language on both signs, if you're traveling in the northbound lane, all of the signs are in the Salish language. And if you're traveling in the southbound lane, all the signs are in the Cooney language. This is one of the crossing structures under the highway. There are varying sizes. We have the larger ones and the smaller ones. And a lot of those were placed on the landscape where water was moving under the highway so that animals are attracted to the area. So we have arch culverts. We have wildlife fencing to funnel wildlife to the structures. And the fencing has like a dig barrier so that bears and coyotes can't just run up to it and dig under the fence. We also have jump outs, which the goal of those is in fenced sections that wildlife are able to jump off of the highway section and into the safe side. So they run up to this perpendicular fence. You might have seen this before and everybody's like, what's that weird little piece of fence? It's a jump out. And so an animal will run up to it, jump off the structure, and run off into the safe side of the highway so that so they don't get hit by a car. These are just some cool pictures of animals that we've seen crossing under the highway in cameras, remote sensing cameras that we use to monitor. They are motion sensing and infrared so that they can take photos at nighttime. There's an elk using the underpass. We have pictures of moose, mountain lions during the day. Most of the pictures of mountain lions I had were night, but now we have some nice daytime ones. Bobcats, coyotes, fox, a lot of black bears. So we have a large population of black bears on the reservation, and they're very effectively using the crossing structures daily. This is a grizzly bear. We have them using just a couple of crossing structures that we have, but we have multiple crossings by different individuals. You can see those large claws there, those buffy colored claws. Those are used for digging up rocks and mostly turning over material like that. River otter, beaver, badgers, great horned owls and bats. Bats actually prey heavily on, great horned owls prey on bats. So we didn't get to see that happen in this picture, but we see them in the same place. Skunks, not many people like skunks. I like seeing skunks under the structures because that means I'm not hitting them with my car. We also have the Salish, Kootenai, and Pend Oreille Dam. That's a newly acquired hydroelectric dam by the tribes. And because of that dam, we have monies that help us manage land and help us manage the river below the dam. And so we do a project where we measure the vegetation along the Flathead River, and we take photos along the river to show how the vegetation has changed over time. A lot of what we do also is outreach and education with youth. And so we have the annual river honoring. I think we're up to 1,000 students come from all over our region to kind of learn about managing resources, natural resources. I show this picture because she's holding the iPad, and I'm going to show you our app in just a few minutes, and it's a free app that you can download. But the cool part is that we can use the information from the application and use live things, like we have a rehabilitator that brings injured birds so that we can talk about birds, they can talk about birds, and kids can actually see live animals. We really try to keep our cultural connection. That's what keeps us connected to the land. And using our language is one of those big parts. So I'm going to go ahead and show you this app really quick. Okay, so this is a free app that you can download. And I'm just going to go through a couple different things on here that are kind of cool. One, we can go to the carnivore. So I'm going to take you back out to the main app. This is called the Animal Field Guide of the Flathead Reservation Riparian Species. Riparian meaning the vegetation and habitats that are around rivers. So if we go up into identify, one of the cool things you can see in here, if we go to mammals and carnivores, is we can select the grizzly bear. And this app shows you some biological information about it. It talks about cultural information about grizzly bears related to the Salish Pend Oreille, as well as the Kootenai people. So each reservation is different and each tribe is different. And different tribal people have different relations to animals in different ways. So the information that's in this app is tied specifically to the Salish and Kootenai people. Some of the cool things on here are tracks, identifications, but they also have the sounds of animals. I hope you never in real life. One of the other cool things is that the Salish and Kootenai people have even put the language and the names to all of the wildlife species included in this app. So here's the Salish name for grizzly bear.
Some
And the Kootenai name.
Ksausa.
And we have the English and Latin name, which is Ursus arctos. So when we in science talk about different wildlife species, we generally use their English and Latin names. But now because of this app, we can even use Salish and Kootenai names. Another good one is the gray wolf. Again, showing the cultural about it. related to that species. Oops. Sounds. And the sailor moon.
Season. Season.
And Kootenai.
Kaken. Kaken.
So it's more than carnivores. You can go through there, and I encourage you to download it and play with it. It's a free app, and you can look at amphibians, reptiles, fish, birds, and mammals. I do teach a class at Salish Kootenai College, and we use this app. But we also started looking at other reservations and other tribes to see if they had language apps as well. And we do find multiple ones. There is one for the Blackfeet tribe. I downloaded yours, and it has names of wildlife species on that as well.
Awesome. Well, thank you so much. So what we're going to do right now, Paul, I'm going to have you come back on. This is the time where we can ask some questions. So that's a lot of really great information. And maybe we'll start by just going through some schools. Is there a school right off the top of the bat that has a few questions? You can raise your hand that you're dying to ask. We'll get to visit every school. All right, let's see. Is that Great Falls? Go ahead, Nicole.
So the more like rounded the rivers are, does it mean that there's like more vegetation that can grow and like help the fish?
Yeah, so a lot of rivers, when they do get straightened, if you picture a pipe and you put a bunch of water in a pipe, it just blows out and goes really fast. There's nothing to slow it down. But natural rivers have a big sinuous snake-like pattern, and therefore there's more surface area for vegetation to grow, and the vegetation also acts to slow the water down and hold the banks together. So yeah, that's a good question.
So how do you know when you're shocking the fish to count them that it's not like causing long-term problems?
That's a good question. So you actually test, so the amount of electricity that we put into the water is very measured, and so you do, and Whisper can probably help me with this a lot more because I'm not a biologist, but you basically test the water and the conductivity, how much sediment is in the water that can hold electrical charges, and then you adjust your backpack shocker accordingly. So if you're shocking them too much, it'll kill them instantly. But if you're not shocking them enough, it won't stun them to the point where you can't catch them. Hopefully that's correct.
And I think that it's just like monitoring any wildlife species that you capture and get in hand. You're collecting data off of it, but you need that animal to keep living in the system in order for that data to be meaningful. So the whole goal is to, if we touch animals that we want to be out in nature, that we need to do the least amount of harm. So it's a measured thing that we make sure that they're not impacted long term.
Cool. I think we have another guy that has a LiDAR question.
Yeah. So does it just take one passover for the LiDAR to create an accurate image, or does it take multiple?
Yeah, it just takes one, and the technology is becoming more readily available and more accurate. I think that they're able to distribute more light pulses per pass, and it's also, the technology is getting down to the point where it's small enough that people are fitting them onto drones. And so this technology right now is almost prohibitively expensive for projects, but I think in the near future, as technology evolves and these systems become more affordable and usable and smaller, we'll probably be able to use it quite a bit more to develop our projects.
So, have you ever messed up and zapped a whole stream of fish dead?
What was the question?
Have you ever zapped a whole stream of fish to death?
Me personally, no. I'm just an engineer, though.
And the tribal natural resources department has a specific fisheries department. So I work for wildlife, but they're specific fisheries biologists. They have never reported that they've killed a whole stream of fish. I'll leave it there.
That's a good thing, I guess.
Sentinel, how about you?
I guess you Whisper, but I was just curious, what made you to go to pursue a career in specifically wildlife biology, and why? What do you like most about it?
So when I decided to go to college, I was just kind of working jobs, and I got a catalog for Salish Kootenai College. And so I started looking through their degree programs. And initially I was going to be a nurse, and I started working as a nurse's aide in a hospital, and I decided that if I was going to keep in the sciences, I'd rather be outside for my career and be able to walk around in natural light. And so I went through the catalog and found environmental studies, and it turns out that was the right choice for me. I guess my best thing about my job is getting to talk to different people about it, getting to research a lot with the highways. One of my favorite things right now with the camera monitoring project is getting to just watch different wildlife that you wouldn't normally see walking around the landscape, and I get to watch them just living life and just kind of walking around doing their thing. It's really kind of a fun part of my job.
So, this is, I guess for both of you, is there like a way we can get involved and help out with, say, like fish counting or doing stuff?
You know, there's a group called the Wildlife Society, and sometimes they have high school chapters, or they have chapters. So I know there's a pretty active one at Montana State University and the University of Montana. And if you looked up online or on Facebook, either of those universities, the Wildlife Society, you could contact their student chapters, and they will try to make projects to come and work with students. I think. I'm not there, obviously, but that's one of our goals as a club, is to do that and make those outreach.
Yeah, and similarly, Trout Unlimited is always looking for volunteers. There's local chapters. You can look up your local chapter online, and there's monthly meetings, and it's really easy to just go to a chapter meeting once a month and see what projects are going on. We're always looking for people to help plant willows or fix riparian areas, and there's always something to be done. So lots of opportunities.
And really quick, we have high school teachers that will contact our office, mostly out of Ronan or Polson, because that's where we're stationed. But we've come up with different projects to go out and do with high school teachers. So even if you have a teacher or a club, you can contact a local wildlife or fish agency, and a lot of times they'll come up with a project to go out and do with students.
How many animals you saved from like the work of like helping the rivers and helping the animals?
I'd say the northern leopard frog has been saved. We didn't have any on the reservation, and we think that's from some pollutants from agricultural uses. And now that we've been able to reestablish them, those animals will be back. The trumpeter swans were not at all in the Mission Valley, and now we have collared ones that we reintroduced, plus non-collared ones that were actually born there. So those are two species that have done wonderfully because of human involvement.
Yeah, and similarly, we've had two streams that have been reconnected in the last 5 years in the Middle Clark Fork drainage that previously had been disconnected through mining, where the streams didn't actually touch another stream. They just went into mining pits. And we've restored those in the last 5 years, and now we have spawning cutthroat making it out of the main stem of 9 Mile Creek up into these tributaries like they did 100 years ago. So I don't know the number on that, but we've studied it, and it's been over the hundreds every year.
When you mean like cut the willow trees, you meant like you cut off the branches to go plant them near the riverbed, right?
Yeah, and so we usually wait till this time of year because the plants are going dormant. They're getting ready to basically go to sleep for the winter. So we wait till they store all their energy and we cut them, and then actually just cut the branches and you bury them in the water or deep connected with some groundwater, and they'll sprout new plants next year. So I was actually out on a project this morning putting willows in a new riverbank that we're building out in Cedar Creek for bull trout. So it's very effective, and it's very cost effective because it's not very expensive to cut willows and put them in the ground.
How many fish do you collect each year when you're fixing the rivers and whatnot?
Well, it depends on the size of the stream, and I should probably clarify, we don't really collect them. We just when we're doing that, we're sampling for species and numbers, and usually in a healthy small stream, you do 100-meter reaches and you'll get close to 100 fish in a 100-meter reach on a small stream. But for instance, that picture that I showed there, I think we got 14 fish in 100 meters. But we're getting ready to resample the stream where we fixed it adjacent to that, and I expect it to be in the 100 to 200 range for 100 meters.
Thank you all for being a part of STEMfest today, and we hope to see you again soon. Goodbye, everybody.